Hello everybody and welcome back to Flutter series. Today we are going to talk about asynchronous state in Riverpod. So far, all our data was available immediately. In real applications, data often comes from the internet, a database or a file. In this lesson, we learn how Flutter handles data that arrives later. Asynchronous data is data that is not available immediately. So, for example, network requests, database reads, file loading. The application must wait for the results. So how Riverpod handles async state? Riverpod provides special providers for async data. One of them is FutureProvider. FutureProvider represents data that will be available in the future. We will create a provider that simulates loading data. Now, let's go to logic counter notifier and let's add this code below final counter provider. Async counter provider equals future provider of type int ref async and then await future dot delayed, and we are going to put a custom duration of 2 seconds and return, let's say 42. This provider returns a future. The future completes after 2 seconds. When the future completes, data becomes available. This simulates loading data from an external source. We now display this async data in the UI. So go to counter page and let's update our body, but instead of this center, we are going to write let's comment out this one for now, and then let's again center, in which the child is going to be a consumer, in which consumer the builder is going to be context ref and an underscore. We're going to explain everything in a while. Then as async value, we are going to assign towards our async counter provider we created before and return async value dot when this time. Here we are going to pass value and a text that's going to represent our loaded value, and with a dollar sign this value. As a style, we can add, sorry, here as style we're going to add text style with font size 32. Okay. As error, we're going to write error tag stack and then a text which just simply going to say that something went wrong. And for the loading, through a lambda runnable expression, we are going to call a circular progress indicator. This one is the correct one. And here, hmm, where is this closing? It's closing. Okay, so after this, need a comma. Okay, and in the end here again a comma. Okay, so the future provider returns an async value. Async value represents three possible states. These states are data, error, and loading. The when method allows us to react to each state. So it's like saying to the provider that, okay, I know that you are going to return a value, but and when you return it, I'm going to evaluate it that if it's data, then return this. Take this value, whichever is this value, and show it. If we have an error, then instead of crash, let's show this. Otherwise, if we don't have any of these two and we are still in loading, then we are just going to show a circular progress indicator. So when the provider is still loading, we show a loader. When the data arrives, we see the value and the UI updates automatically when the state changes. If we run this, you see the indicator and nothing else happens. This is because we use this in order to return a specific value, which is, of course, we also manually add the delay. In real world, it doesn't work like this. In real world, for example, we would wait for an API response to be success or at least to be finished. So with async state, the UI does not wait, reacts to state changes, and Riverpod manages transitions. This keeps the UI responsive. Almost every real application uses asynchronous data because this pattern allows smooth loading experiences, predictable UI updates, and clean async handling. In the next lesson, we will manage async logic more explicitly, and we will combine state notifier with async operations. Until next time, see you!